Hello everyone, you're welcome to my YouTube channel. In this video, I will continue from where we stopped in the part 2 of the exploratory data analysis with Pandas. And so we will go straight to look at the final part of this subject matter. Here I will import the respective libraries, Pandas, Seaborn, and Matplotlib for visualization. And so what I would do next is to load my data from the directory. So this is where my data is kept in the directory. And mind you, in this population growth underscore version 2, as I did it in the previous video, which is the first video, I did clean up this data and save it. I used the first column was the country code, but I cleaned it up and used the first column as country name. Then, so we have this data, which is a clean data. What I would do is to proceed and use pandas.read CSV. Like I mentioned earlier, you can also use something like this. If you have your data in SLS, which is the Excel format, you use pd.read Excel, and then you pass in what you have here, which is the location of the file with a file name. So something like this. If you run it, you have same result. The data will be loaded. So here we have our df in the namespace. What we do is to print. Let's see how the data looks like. So we print the head. See, it gives us the first five rows of the data. You can see column names, and then you can see here we're looking at population growth index for different countries in the world. If you want to have an idea of what the data looks like, you can simply also call df.info. Run df.info. What do we have? It gives you, you see, exactly the details. We have 217 non, null, and then the various object type in the data. And then finally, the memory usage when you load the data. The next thing we can do here, we can sort this data by different columns. So let's sort it by any of the years, and then to sort that, what do? We say df.sort values, and then in as a parameter by, we set it to 2002. If you run this cell, it sorts it. You can see it is sorted. If you check in this here, you can see 145 coming first, 29, and then the country. So the data has been rearranged and sorted but by default in descending order. So let's say the sort format. You can see you go to what we have here. This is 2002. You can see. So it sorts that the whole data frame using this column values for the year 2002. We can as well sort by another year and then apply ascending to be false. If you do that, you see we're using the year 2005 and it sorts it in descending order. Watch out for the indices again. It has been altered. Next, what we can do here, we can check again, just because we're doing exploratory data analysis, we can check if we have null values, okay? Where we have null values or empty values. So what we do is called df dot is na, and then you sum it. If you print df dot is na, it gives you all the data frame, but if you sum, it tells you the total number of the null values you have in your data frame, if there exists any one. So you run it, you can see that we have no null values here, both from the country name and all the years taken into account. There's no null value. And then the integer type, you can see the data type is int 64. Next, we can look at the brief statistics of the data frame. So we'll call print df.describe, and I transpose it. I want to transpose the results. So if we run this, we can see the count, which tells you the number of elements in each of this column, the mean, the standard deviation, the 25th percentile, the 50th percentile, and the 75th percentile, go forward, and also the maximum value. Now, what we can do next here, we can look at how these data are correlated by looking at the uh, correlation values. How are they related? Okay, to do that, remember that our data has the first column with strings, so we're going to exclude that first column with strings. Otherwise, Panda is going to drop an error that you cannot do that with that string data. So that's why I select all rows and I start from the second column until the last, right? So that excludes the first column, which is containing the country names. If you run this, you can see how you can see the correlation. Okay, so it gives you a full map of the correlation values for all the data. Okay, the years, how they are related. Now we can visualize this, instead of just printing the table, because here we are doing explorative data analysis. So what we do, we use a Seaborn and then use the heat map from the Seaborn library. Also pass in the respective correlation values you want to visualize and put annotation is equal to true and not set it to true. And then here I've used the matplotlib to set the figure size and then to show or display the figure. If you run this, what we have, it gives us, you can see, it gives us this in a second. Yeah, it gives us the full map and then uses this figure size, 16 by 4. That looks a little beautiful. So you can see the correlation values. Okay, you can see the values ranging from zero point 0.5 until 1.0. Where you have 1 on the diagonal shows a strong correlation between the values. You can see strong correlation between 2000 and 2000, but how year 2000 is correlated with year 2001 is 0.88, with year 2002, and so on and so forth. So this gives you a full view of the correlation of the data. Now we can simply do something by compute the mean, and then we use the group by, and then we'll pass in the country name. If we do that again, you see it computes the mean, grouping them by the countries. Okay, you see the country names, and you can see the respective mean for the different years. Okay, across each of these countries. Next, we can also sort this mean value. So what we do is that we can sort it. We have group by country name dot mean and then sort values. How do we sort it? We sort it by using the year 2007 and we want it in what? In descending order. So we set ascending equals false. If we run this cell, it gives us exactly, you can see it's sorted. So it's showing Qatar, okay, value for 2007. You can see the mean value as high as it is, and it goes down, down, down across the column. Next, again, we can, yeah, this is same thing we have done here. We can decide to allocate what we want to do here. Now we have sorted this. We can decide to, plot these values, okay, of this mean. So we do df. To do that, we have to, assign it to another data frame, df2, and then we'll do df2 equals df dot group by name country mean sort values by 2017 and ascending order. If we run this, we have df2 in the namespace. We can plot by simply just calling dot plot on the data frame and then specify the figure size and you show the figure. If you run this, you can see how, you can see how the population index is changing with respect to the countries for each of those years. So this is just one way to visualize this. Another way is that if you want to check these outliers, when you want to do outlier detection, is to use a box plot. So all we need to do is to call df.boxplot and specify the figure size and also show. Mind you, we are plotting the box plot of the original data frame, not the data frame 2, which is the mean values. Okay, here we plotted the mean values, but here we are plotting the original data frame. So running the cell gives us the box plot, and we can see the outliers, okay, by looking at down, see 2006, 2007, and 2008. 2008 has a max, 7 has the maximum outliers up there, and then we can look at, down, 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 down. We have less outliers in 2001, 2002, 2003. 3, and so on and so forth. So this is just the way you can visualize the box plot. Next, we can check the data types. Okay, so country is an object, and then the all the other substantive columns have their data type. So what this helps us do is that we can use this data type to query the data. In other words, we can use it to change or to select some data. Okay, so for example, we can call here df.select d types include float. So I want only data with floats. Okay, if I do that, what happens? You can see the country name has been excluded, and all data that has a float value, that float 32 or 64, is returned in my data frame. This is one way of dropping off string values, and another way is to do what to drop that particular column. Another way of doing it is to use the select d types and then select the numeric data type that you want to use and then assign it to another df. You can as well also write it to an output file. The next here is I want to look at the covariance, because here we're looking at exploratory data analysis, like I mentioned earlier. So look at the covariance, of course, the covariance of numerical values. So we drop the first and pick the second column onto the last. If you plot that, you see it gives you the covariance of this data, gives you the covariance of data. And then again here, I can repeat the correlation, but here I use which method? We have the Spearman's method. We know what we have: the Persons method, we have the Spearman's method. So if you run this, it returns also the correlation values for the years of that data. The next thing we can do, we can look at the skewness, and this tells us about the distortion of the symmetric distribution. Here is symmetric, the symmetric distribution or the asymmetry, in a data. So we're looking at the symmetric distribution or the asymmetry in the data, and that this is a formula to compute the skewness. But in Pandas, we can simply call the numeric values and then dot skew, and that gives us the skewness. So you can see the skewness in the data for every of the years. You have the skewness value. Another analysis we can do is the kurtosis, and that tells you the fourth standardized moment. This is the mathematical expression for that, the formula to look for that. But in Pandas, we can get the kurtosis using a dot cut or dot kurtosis, mind you, of the numeric data. Run this, that's the kurtosis. You can see if you run this also, you see we have similar results for both methods. So you use the cut method or the kurtosis method. Next, we can also find the mean of this data. Okay, so to find the mean, we simply pick the numeric data dot mean, gives us the mean values. So return all the mean values for every year. Mean values for every year. Likewise, we can find the median, returns the median. We can find the standard deviation as well. It returns for us the standard deviation. We can as well find the cumulative sum of these values across the years. Okay, so it sums the first and second and cumulative sum of it. If you run that, what do we have? It gives us the cumulative sum. You can see it for the respective years. And then what we can do here is that we can visualize this cumulative sum. So we do df.ilog. I'm using ilog here because I want to use the indices. And then I pick the numeric values dot cum-sum dot plot and then show the plot. And then automatically you can see the cumulative sum for the years on the 2015. The last we are going to show is to plot the histogram. So I can plot the histogram to see the distribution of this data. So for every year up to 2015, I can show the histogram. So to do that, I just call df, the original df. You don't need to remove the label index, okay, because it picks only the numeric data. So it will plot for every of those column. So you run this and show the plot, takes a bit time, and then it shows. You can see Year 2000, you can see the distribution of the data. Also here, you can use to do anomaly detection, okay, to check anomalous values. So you can see it 2000, 2001, 2002, 3, across the years, how the data are distributed until the last one, 2015. So the take home here is first, we have been able to show how we can do explorative data analysis, okay, and then visualize our results. Find this video interesting, give it a like, share this video with your friends and colleagues. Also, don't forget to subscribe to my YouTube channel and ensure you click the notification bell when you subscribe to get notified whenever I drop new videos. In my next video, I will be discussing introduction to object-oriented programming. Till then, I will see you in my next video. Bye.